coming. It's good to have you here. I'm going to be speaking about microservice architecture and in particular about how you can use Spring Boot along with Groovy and other technologies to achieve that goal. So just a very quick word about myself. I'm a Java developer. I've been doing Groovy for the last 5 or 6 years. I work in London and I'm working for a consultancy at the moment with Equal Experts. And in my spare time, I really enjoy working on open source software, and in particular, my pet project, which is GBM. And then you can catch me blogging sometimes at wiredforcode.com, and I'm on Twitter. So, in this talk, we're going to be covering the following few things. We're going to first look at what microservices really are. We're going to just look at some basic concepts. Then we're going to look at, just very briefly, at Spring, and then look at Spring Boot, what Spring Boot adds to Spring. And we'll also look at some Spring Boot components which you'll be using to build an application. And then we're going to do a live coding demo where we're going to actually build one from scratch, but doing it slightly differently. We're going to be doing it test-driven with Spock. So anybody who knows me knows that I love testing, so we're going to try and do this from a test-driven approach. Right, about the demo. The demo has got a bit of a theme. So it's based on a cartoon called Invader Zim. It's an American cartoon that aired on Cartoon Network in the early 2000s. It was discontinued shortly afterwards because of 9/11 happening that year. I think people just weren't in the spirit for that sort of thing. The theme of it is impending doom. So, and the main characters, the protagonists, are Zim and Ger, and that's what they look like. So just keep that in your mind. We're going to be building our little demo app around that. So let's get right into it. Microservices. So where does that come from? You've probably heard it being bandied around a lot over the last while. Everybody's speaking about microservices. And it's actually become almost a bit boring. It's just become overused, the term. Like anything, actually there's nothing new under the sun. So all that microservices really are is what we had originally in SOA, but it's evolved slightly. And then somebody came and stuck a label on it. Now there's lots of hype. But let's look at microservices from a more objective view, and let's see how we can actually benefit out of it. So it all got started by a guy called James Lewis. He's a principal consultant for ThoughtWorks. And he did a talk early last year, I think January last year, that went onto InfoQ called Java the Unix Way. And he basically explained a project that they'd done using a slightly different approach, because they had to deliver a huge monolithic application. So they decided, well, if we're ever going to deliver this, let's break it up into smaller bits. So that's what they did. They essentially broke it down into small bits, used some alternative technologies, and he used the word microservice, I think, and that was it. The phrase just caught and everybody started using it. So I'm just going to take a few points out of his talk and highlight those, because it's a really great talk. It's on InfoQ, you can find it there. There's a link in my presentation as well, so you can just go and watch the talk. It's 45 minutes and it's well worth it. He says, firstly, microservice architecture, small with single responsibility. So small in comparison to what? So in the olden days, we used to build these huge applications, these huge monolithic applications that served all sorts of endpoints, and you had a giant WAR file that you would throw onto an application serve, onto WebSphere application serve or something, and there you would have your application. So this is taking the opposite approach, where you're actually having a single responsibility for your application. You have tiny, tiny applications that don't get deployed onto an application server, but that actually come with an embedded container. So, single function. Interesting enough, James Lewis says that normally, just as a rule of thumb, it's about 1,000 lines of code. So I heard Jeff mention that yesterday in his talk as well. He said he didn't really agree. I'd actually take it to the other extreme. If we're using Groovy, we don't need 1,000 lines of code. We can do it in a few hundred. Right, and this is a big advantage. If you're writing very small, fine-grained applications, they're easy to throw away. We all know that writing the code, or the actual code itself, is actually very cheap. What's expensive is the lessons learned in writing that application. So the nice thing about this is, if you've written the application and it has maybe gotten out of hand a bit after a while, you've learned your lessons. Just literally throw it away, write a new one. It'll take you a day, and you'll have something fresh and new. Also, you might choose to use a totally different technology. That's the advantage. You can use any technology for this you like, because it's totally self-contained. As long as it runs over HTTP, it all works. Right, so I mentioned this earlier, containerless Unix process. So typically these things run with an embedded container. You'll probably use Tomcat or Jetty. I prefer Jetty because Jetty is even lighter than Tomcat. And they normally come as an executable fat jar. So that's basically a jar with all the dependencies inside. Somewhere in that jar there's a public static void main method, and you've got a pointer from your meta-inf artifact inside the jar pointing to that. So when you go to the command line and you say java-jar and give it the jar, it will automatically just start up your container. So this is something I've done, and it's worked really well, is to help the DevOps guys. I package the fat jar inside an RPM file. So RPM is the Red Hat Package Manager artifact that you can install packages on Red Hat or CentOS. So this is really handy because now you can include a startup and a shutdown script inside that, that package. Give it to the DevOps guys. They just say RPM -I, giving it the package. Automatically uninstalls the old service, brings it down gracefully, installs the new one, and starts that up again. So it makes their life a lot easier, and you can automate that very easily as well, the installation. So that's just using the Unix server script. Also, the way we look at version control, this is interesting. The way we look at version control has changed drastically as well over the years. In the past, we had centralized version control. We had Subversion or CVS, and you would check all your code of all your projects into one giant repo. So now that we're on a distributed VCS like Git or Mercurial, it's far easier to have fine-grained version control. So you can basically map one repository to one microservice, which is really nice because now you've got a log. If you look at your version history, you've got a log, the story, the change log of just that specific microservice reading like a story line by line. So that's really nice. Also, if you want to throw it away, like we said earlier, you just get rid of the repo, or you just tar it up, put it away, and create a new repo, and there you go. Right, so because we are writing very fine-grained applications, it's actually fine to have some duplication in your application. You're typically not going to have many domain entities, for instance. So you'll have 2, maybe 3 classes, and maybe you'll have those same classes repeated in another microservice. That's fine. If we learn to live with it, that's all right. It's better than extracting a domain package that we have to now share among all our applications. And in other words, if we upgrade the domain, then we have to redeploy all our web services. So it's fine to have a bit of duplication. If you do have infrastructural code that is duplicated, it's very easy to extract that to a jar and just put it in where you require it. So I'd say rule of thumb is if it's very low in the application, live with duplication. But if it's quite high up and you can just pull it in as a dependency and use it somewhere, then it's fine. Right, another big advantage we get from microservices is they can be status aware and auto-scaling. So a lot of these frameworks provide you with in-app metrics. So that allows you to monitor the health of your application and actually take a look inside of your application and see what's going on. Also, typically you'll expose ping and health endpoints in your web service so that you can have watchdog processes sitting outside your application looking in. Advantage of this is if the demand for your service grows, it's very easy to just spin up new instances. And all of this can be done hitting those endpoints. If you want to scale down again, then you just throttle down again, you just destruct some instances. But all of that can be done by looking at the internals of those applications to see how they're performing. Right, so in terms of frameworks, we have lots of frameworks to choose from, and lots of different technologies as well. So we've got Sinatra for the Ruby crowd, Play for Java and Scala, Django, Dropwizard, Vertex, Grails, Ratpack, and of course, we're going to be looking at Spring Boot. Just a word about Ratpack. It's also really worth checking that out. It's a great little framework, and it's also very, very well suited for this sort of thing. Right, so I'm going to go very fast over Spring. Has everybody used Spring in the room? Well, if you're using Grails, you're using Spring, right? So everybody knows where it's come from. I'm not going to say too much about it. It just gives us great dependency injection. It gives us glue so that we can integrate with other technologies like JDBC or an ORM or JMS or you name it, it's probably supported. And it gives us great extensions. So we've got spring-mvc, we've got Spring Data, which we're actually going to be using in the demo, and Spring Security, and so forth. The list goes on. Right, the bit I want to speak about is Spring Data. So, Spring Data, on their website, they've got a definition for what it is. So they say it's the umbrella project which aims to provide a familiar, so that is quite a mouthful. So, I started thinking, what are they actually trying to say there? So, in essence, what I think it is, it's actually a giant command pattern. All they've actually done is they've abstracted data stores and exposed it as a unified interface for us to use. So no matter what data store you're trying to use, you just plug it in. But the way that you interact with it from a Spring perspective is just literally through that unified interface. So it helps us speak to no SQL data stores. So you can plug in Mongo or Redis, Neo4j, Hadoop, there's a whole bunch of them. And these days you can also plug in relational data stores. So it's very easy to use it with JDBC and JPA. Forms an umbrella project, so each sub-project, each repository that we integrate with, like Mongo for instance, has its own project. And these projects all fall under the Spring Data umbrella project. Good. So what we're going to be doing is, in our demo, we are actually going to be using some of the Spring Data components to handle our persistence for us. So firstly, we're going to be using the abstract Mongo configuration. Just sorry about the blue, I know it's not very visible. I'll actually just... So we're going to be using the abstract Mongo configuration. So this is a convenience class they give you to extend, which allows you to simply implement two methods. And in those two methods, you tell it what the name of the database is, and you tell it, or you basically give it an instance of Mongo driver, which you can configure yourself. And that will automatically go and connect to Mongo, and your application is speaking to MongoDB. Mongo interface, Mongo repository interface is also very handy. It's literally an interface that you extend, and then at runtime, Spring comes along, and it goes and gives you an implementation class. It implements it on your behalf, giving you all sorts of convenience. So on that repository interface, there are all kinds of CRUD methods. So you can create, read, update, delete data. It allows you to do paginated list views. And it allows you to just add new methods to your instance of that interface for finders, very much like Gorm. We'll explore that as well later. Obviously, it gives you unified data access exceptions, which is a runtime exception, and it does object mapping all for you. And it's literally, you'll see, it's just a few lines of code. It's very useful. Right, so Spring Boot. What does Spring Boot give us over Spring? So first and foremost, it turns Spring into something very similar to Grails. So I think one of the biggest wins we have with Grails is that it's all convention over configuration. They basically give you sensible defaults for everything. You've got to configure almost nothing. I mean, we all love that, right? Grails create app, and boom, you've got it all. You've got a whole Spring app, plus a lot more on top of it. So what Spring Boot does is it gives you something very similar. It's opinionated, and it gives you great sensible defaults. It auto-configures all the things you need, like the embedded container, all those things that you want, view resolvers, you name it. It's all done in a very standard way. They give you Jackson under the hood for marshalling, and it's all there. It also allows you to build standalone apps, which is exactly what a microservice is, with an embedded container. Also, in the source code, you'll find folders full of starter template projects. So if you want to write a project that works specifically with Mongo, they've actually got a little startup project that you can just pull out and copy over somewhere to start your own microservice, and you just start filling in the blanks. Also, comprehensive examples of how to integrate with all sorts of third-party technologies. Gives you metrics. You don't have to write any XML like in the old Spring. And we can write all our code in Groovy, which is obviously the big advantage here. No Java needed. Right, so let's take a quick look at some of the components that we're going to be using. So firstly, our basic starting point for every application is an application class. So this is where our public static void main is going to live. That's our bootstrap for our application. An application can also have 0 to many configuration classes. So can I just see a show of hands who's used the Java config in Spring? Yeah? So this is Spring's new way of configuring applications. Rather than in the old way where you had to use XML to wire all your beans together, you can now do this inside Java configuration.
It's not that new, it's been around since 2007.
Okay. Well, only 3 people have heard of it here. Okay, so that's an example of an application class. So there we have it. We instantiate a new Spring application, passing in the class that we're currently in. And then once we have that instance, we call the run method and pass in arguments. So you can actually pass in arguments from outside into your application. So why do we give it that application? It's because of these annotations on top. We've got an enable auto configuration annotation, which kicks off that whole auto wiring process. And we give it a component scan annotation as well to tell it where, in what package to look to start auto wiring all the components together. That's an example of a configuration class. So the configuration class, this is actually the Mongo abstract configuration I was telling you about. You literally extend that class, and there you implement a method telling you what the database name is, and you just instantiate a new Mongo instance, and off you go. That'll start speaking to your local host on the default port. Right, then this is a standard kind of approach that we use in Grails as well. We've got controllers handling our routing logic. Then we've got a service class typically, or service classes, which handle the heavy lifting, the actual business logic of the application. And you have repositories for speaking to the database. And then you have model objects, which basically bring data back from the database and you can use throughout your applications. So that's basically what a controller looks like. In Spring Boot, you'll see that we have to annotate it with @controller. You can see this is Groovy. So at controller tells Spring that it's a component, and Spring will automatically pick that up and start wiring that in. Request mapping tells the container where to mount this on the context root of the application. Then we have a repository and a service. Both of those can just be auto-wired in. We just tell Spring to auto-wire them in if we have those things declared in our class path. Another request mapping that gets mounted on top of the previous one. And we have a path variable there. So this is interesting. We can literally just add an ID onto the end of our URL, and that will automatically be placed inside that string parameter that gets passed into the method, because we have the path variable annotation there. So this is all basic spring-mvc stuff. This stuff translates directly from spring-mvc. We return a response entity, which is a really handy way of just encapsulating a response and giving it a status code. So you'll see here at the end here, I instantiate the new response entity, giving it a domain object and telling it that it's going to be HTTP status OK. And of course, we just have to annotate the response as a response body. So then Jackson will just pick that all up, convert it into JSON, and pass it back to the client. So there's very little manual configuration to get any of this done. This is all actually provided for you out of the box. Right, there's our service. Nothing new here. Looks exactly like we have in Grails. We just give it a @service annotation, stereotype there, which is once again a component. Right, this is the really interesting one. So here we have the repository. So you'll see we basically just extend the Mongo repository, which is provided by Spring Data, but we parameterize it with the domain entity and the primary key that we're going to be using inside the domain entity. So the stuffing should have a big integer ID inside of it. And then these methods over here, we can add as many of them as we want, as long as by naming convention they match up with fields inside our domain entity. Further, we don't have to do anything besides add that repository annotation. Spring Data will come along and just fill it all in for you. Right, and lastly, our model object. So the model object has an @document annotation. That's basically Spring Data Mongo, telling it to map this to a document in the collection that you're going to be placing it. By default, it's going to use the name of your entity to pick up the name of the collection that you're pushing into. You'll see there's an @ID annotation and just fields for all the fields that you're mapping. And lastly, your build.gradle. So very simple. In the build script section over here, we're basically just bringing in a Spring Boot Gradle plugin. So why do we need a Spring Boot Gradle plugin? It's basically so when we build the fat jar, it actually will go and collect all the dependencies, bundle them all into the same jar, and it'll generate that manifest for us, which points to our public static void main. So that puts us in a position where we can literally run this up with Java, and our application will start up. And then we just need some basic dependencies for the annotations that we're using. Right.
What did you learn? I saw a squirrel. He was doing like this. Concentrate, girl. It is time for disguises. I want to be a mongoose. Will you please stop singing? Proximity warning. Flight header.
Great, so that's Invader Zim. Go and check it out. It's really, really good. Okay, so what we're going to do is going to be something very, very simple. We're going to write a quote service that's going to allow us to bring back Invader Zim and Go quotes. We're going to be passing in via the URL the name of the invader, and it will return a quote for us of the corresponding invader. So literally you can test this out in the command line by running curl -s, giving it the host and the port. We're going to have an invader controller, and that's going to take the path variable sitting on top of that. So pretty much what we've just discussed we're going to actually do now. We're going to see a response something like this. It's going to be obviously at 200, and there's going to be a snippet of JSON returned with the ID, the name, and the message. Right, so let's get right into it. So for starters, I've already set up the basic application, so the build is already in place, everything is there that we require. I've also written some functional tests using Cucumber, especially for Bert. So there we have it. This describes what our application is going to do. There's two scenarios, one where Invader Zim quotes by name, and the other one is where we get Invader Go quotes by name. So given an invader named Zim, and the Invader Zim says that when a quote is requested for Zim, then we hear it. So, and the same thing for Go. And we've already got step definitions set up for that. Can I just see who was in my Cucumber talk yesterday? Right, fair enough. So you'll know what I'm talking about. That's all done for us. We're persisting things to the database using the Mongo client. So that's all set up and working. All we need to do now is go and fill in the blanks and actually implement the components that are going to do the work inside our application. So let's start off. So we spoke about starting off with a bootstrap class. So first thing we'll do, can everybody see that, by the way? Is that, let me just make that bigger for you. That better?
Yes.
Okay. Great. Okay, so the first thing we'll do is we'll create that bootstrap class. So it's a Groovy class. It's called application. You can call it what you want though, doesn't matter. The important thing is it needs to have a public static void main method, and inside there we're going to instantiate a Spring application. And we're going to pass it the class that we're in. And we're going to pass through the arguments. Once we've passed in the application into the Spring application, we have to enable auto configuration. And let's do our component scan. And our package is simply Zim. We'll just put everything in one package for simplicity for the demo. Right, so if we now run this up, sorry, I'm just going to have to switch there. If we run this up, if we run a Gradle clean check, then you should basically see the application starting up. Hope you can see that. There we go, it's going to start up MongoDB. There we go. It's going to assemble. Now it's building the wall or the jar. It starts up the jar. Now it'll run the functional tests and they'll fail horribly. There we go. And it'll shut everything down cleanly again. Okay, so let's write some components. Let's start off at the beginning with the controller. So we're going to start off just writing an invasion controller. Right. And like we always do, of course, is we start off with a nice test. So we are going to use, ooh, what's up with that? IntelliJ. We're going to start off with a Spock specification. So we're going to put it under test Groovy. There we go. Let's bring that in a bit. Okay, so that's our specification. Let's start off. And we're going to do a setup. And we're going to instantiate our controller. There we go. Add a field. Good. So now we've got a controller. Let's write our first behavior here. So the first thing we want to do is our service or our controller should successfully respond with a quote for Zim. Right? Good. So the first thing we want to do is we want to on the controller, we want to call a method called quote. We write the code that we wish we had, which we don't have yet, and we want to pass in a name. And in response to that, we want to get a response entity of type quote, and we want to pass in a big integer. Right, so obviously, and that's a response. There we go. Obviously, half these things we don't have. We don't have a name yet, so let's go and create a name variable over there. So def name is Zim. Right, we don't have a quote entity yet, so let's create that. We're going to just pop that into source main Groovy. There we go. And we don't have a quote method on the controller, so let's create a quote method. So there we go, there we have it. Takes in a string of name. So there's the beginning of our controller. Lastly, we just want to do an assertion. So we want to assert then response dot status code, because we said we want a successful response here, right? So is HTTP status okay? So let's run that. Let's see what that does. Can I just see how many people do test-driven development? Good, great. Oh, we've got something wrong here. Response entity. I'm just going to switch to the other view. Right, it says the class response entity refers to, I think I might have imported the wrong one. No, it does look right. Okay, right, so is anybody spotting anything there?
I don't think you need the big integer.
Sorry?
I don't think you need the big integer.
Oh, yes, you're right. You're right. What I do need there is, yeah, that's right. Absolutely.
Test case.
That's right. Good. So that should now fail probably on a null pointer because we're just returning a null there, right? So there we go. That's what we're expecting. Right, so what we'll do is let's just instantiate a new response entity and we return a null inside there. And null, and we'll just give it an HTTP status. So now that should pass. Good. Right, let's do another assertion just inside this test. What we want to do is we want to see that the body has a message inside of it. Okay, we don't have a message yet. So let's add the message. So it's going to be doom. Right, you see that our IDE is complaining here because that quote, the body, is actually a quote object because of the parameter that we pass into the response entity. So let's go and create a message field inside our class. So there we have it. Good. And while we add it, we'll also add a response body name. So we'll add the name as well. So if we add that in there, good. If we run that up now, we should get a failure because obviously there's nothing being passed back inside that response entity yet. Good. Let's do that quickly. So we'll just fake it and we'll just new up a quote giving it the name and the message, which we'll make great, and we're green. So that's a good start. But now what happens if we want to go a bit further? What if we have a different invader? Say now Go needs to come along and also deliver a quote. So what we'll do is we'll just literally be naughty, copy the test method. Don't tell Uncle Kent back. He said you should never copy and paste. So this is going to be Go's quote. And I want to be a mongoose. Right, if we run that up now, our first test should be passing, but our second one will now fail. Right, as we expect. Good. So, let's introduce a collaborator. Let's introduce Spring Data to handle our database communications for us, because we clearly need something to return back data from a data store that's going to contain these quotes. So we'll introduce a new collaborator. We'll literally call it quote repository. There we go. We don't have it yet, so let's create the class, or create the interface rather. Yes. And we're going to use Spock's great mock feature to mock that out. And we're going to set it inside our controller. Good. We don't have a repository field, so let's create one. So there it is. Now, what we'll do is we'll set up an expectation inside our test, which makes sure that that repository actually gets called. So we say repository.findByName. So that's a method we don't have yet, right? Passing in the name. And that should return to us a quote array, or a quote list rather. So we don't have a quote, so let's quickly create one here. Right, so that's going to return a quote if we call a findByName method. And we want that to be called at least once. We don't have a find by name, so let's go and create that. There it is, and we want it to be a list of quote objects. Also, we want it to take a string called name. Good. Let's run that up. Good, and as we expect, we now see a failure because we're not using our repository. So let's jump into our controller and actually start using that repository. So we want to return def quotes, and the quotes are going to come from the repository, find by name, giving it the name. Good, and what we'll do, normally we wouldn't do this in production code, but we'll just say quotes.first. That's just going to bring back the first quote and pass it back to the client. So if we run up our tests now, great, the first one passes. The second one fails because we haven't set up this expectation and we don't have a quote yet. So let's quickly just pop that over into here. So there's our expectation, into action. Good. If we run that, we should now be all green. Perfect. Right, now we need to just sprinkle on a few annotations, and then we should be good to go. Then we've got a working service. So the first thing we'll do is we'll tackle our controller. We'll just add a controller annotation. We're going to ask Spring to auto-wire that repository for us. We're going to add a request mapping called Invader, and we're going to add that path variable that we spoke about. So that's just literally going to be curly brackets, name. And that matches up to the name over there, and path variable. So that says it must match what's in the curly braces to our variable that's coming through. Good, and the last thing we need here is we just need to say that the response is going to be a response body. There we go. Now Jackson will be happy and it will just be able to handle everything coming or returned from this method. Let's quickly step into our quote repository. So the first thing that we need is a repository stereotype. There we have it. We'll see that repository is actually a component. So Spring will just pick it up and start using it. One other thing we need to do, obviously, is we need to extend Mongo repository. And we need to tell it to use the quote and the big integer. And that is literally all you need to do persistence. Isn't that magic? Look, it's not quite Gorm yet, but it's very close, and it gives you a lot of the same benefits. The last thing we need to do is we need to just annotate our quote to be a Mongo document. So you'll see it's Spring Data MongoDB there. And we have to add in our primary key, which is an ID. And we have to give our fields the field annotation. So there we go, field. And that's all we basically need. There we have a complete microservice from scratch. We can now go and run this thing up. Let's quickly run the tests, the functional tests. This will actually prove that it all works. Right, so it's now going to start up Mongo for us again, embedded. There we go, Spring starts up. We forgot something. So the last little bit that we forgot was actually adding our Mongo configuration. My bad. So let's quickly do that. Mongo Configuration extends abstract Mongo Configuration. There we go. It forces us to implement those methods. So we're going to connect to an invasion database, and we're going to return a new Mongo instance. There we go. And of course, this is at configuration, which is once again a component. So if we run that again, oh, that's right. Thank you. That's the right one. Right, Mongo starts up, Spring. Build success, there we go, an entire application. Great. One last thing I would like to do. Do we have just 2 or 3 more minutes? Just the last little bit. This is a really nice bit. If we can just step into our application. So it's an Invader Zim. No, that's the wrong one. Right, so we've got our artifact here. If we look inside our build folder and the build libs, we actually have a jar file there. So we should be able to go and execute this and actually start up our service. So if we start up MongoDB, which already has some pre-populated data, there we go, that's just a local Mongo instance. And if we now say Java, jar, and we say build libs. Right, there's our Spring Boot app starting up. Okay, that's running. If we now try and curl on localhost port 8080, and we try and hit the Invader controller, giving it go, there we have it. There's our response. So status code 200, and there's our JSON. Right, so in conclusion, microservices have just literally evolved from old SOA type monoliths. It's nothing new. They're small. They have a single responsibility. They are dispensable. They're self-contained, and they have embedded containers. And they can be self-aware. And you must take a look at Invader Zim because it's brilliant. Thank you very much.